Γεια σου.
Σου είπε ο Γρηγόρης τι ώρα θα έρθει. 8. Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight. We're gonna be overflying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport. Runway 1419, Lszh localizer landing. Surrounding the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere. Also, we have the altitude indicator with the artificial horizon. You can see the Lszh localizer. We have the horizontal localizer and the vertical glide slope that we receive. We have the radio frequency antennas that transmit the threshold runways antennas of the runways we use for takeoff and for landing, which transmit a radio frequency unique for each frequency tune setting we made, and also for magnetic north pole heading of the runway we have set in the autopilot flight director system panel. You will see later. So we align, we have the aircraft onboard antennas that receive the radio frequency from the threshold antennas of the runways, and align the aircraft with the horizontal localizer and the vertical glide slope, the angle of approach. So we have also the Lszh localizer crossbars. We have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode 1 and 0 with the autopilot and the auto throttle. Later on vertical navigation modes. We have also the SSI, the horizontal situation indicator that displays the magnetic heading and track, and also the decorated display of the flight plan. We're gonna create a flight plan using the flight management computer. You're gonna see later in a couple of minutes. So it's gonna be displayed over here. We're using the flight management computer over here. Will be displayed in the navigation display, both on the horizontal and vertical profile for the flight. You will see the flight plan, or a flight path, or a route as we call it. It's gonna be contain waypoints. We have to fly through the aircraft, altitude and airspeed constraints, and airspeed and altitude fixes and constraints. So we're gonna see them, the waypoints, the seats, these are the instrument departure waypoints and fixes, and the stars, this other terminal arrival waypoints and fixes. You will see the runway we use for takeoff and for landing. We have a lot of information in the navigation display. So we have our own airport. You can see other airports also displayed. We have the terrain weather reflections from the terrain from the weather radar. You can see the terrain displayed with red, green, and yellow rubber indication depending on the distance the aircraft is located from the terrain, and also the altitude difference. If it is above or below the aircraft, it will display red or yellow, green indication or rubber. So you will see. Also, we have the terrain map with the airports where they are located, the navigation aids, the nav aids. So we have the workstations, ADFs, and ADBs, the waypoints which are horizontal and vertical navigation fixes, and altitude and airspeed constraints. You're gonna see we have to fly through some waypoints during this or any flight when we create the flight plan. You can see also other aircraft that fly around our own aircraft using the transponder, the ADSP and ADC. Transmitter receiver that transmits our frequency to other aircraft, and the air traffic control and receives from other aircraft. We will display in the navigation display the other aircraft position up to 40 nautical miles, like 76 kilometers, 70 kilometers. So we have the other aircraft display in the navigation display. We have the distance and the bearing of the other aircraft to our aircraft, and also we have the altitude difference. The transporter computer will calculate the other aircraft location, distance from our aircraft, altitude difference, how many hundreds or thousands of feet are above or below our aircraft. You can also calculate whether the other aircraft climbs or descends with respect to our aircraft. It will give us a warning if we have an incoming collision. You can also calculate the velocity closing in between our aircraft and the other aircraft. It gives us a warning from the TIC system, the traffic collision advisory system, so we'll make an avoidance maneuver in the air. You can also see the other aircraft in the air or in the ground, displayed with a diamond shape up to 40 nautical miles using the TICA system, the Traffic Collision Advisory System. You see the diamond shape of the other aircraft. Also, we have other information. This is how we have the autopilot flight director system panel, the flight management computer we're gonna use to create the flight plan. I'm gonna show you the displays. You will see here we have the yoke we can use. I have this side stick to control the aircraft, the Logitech Extreme 3D. Also, you can see my computer over here, the setup I have for the computer, the keyboard. I can control uh, all functions of the flight management computer. Also, the autopilot flight director system panel using the mouse pad I have here. Also, the side stick I use for the flight controls over here. So we can climb and we can descend. We can make turns to the right, turns to the left using the rudder pedals also over here. So we have I will start showing you the flight controls, the thrust levers. You can see the thrust indication over here when we move the thrust lever to actuate the thrust up and back and forward. If we increase the thrust levers up, all the way up forward, you will see it will display. We're not configured for takeoff. Also, you can see the indications. I will talk to you about in a couple of minutes. First, you will see the displays here. So we have the primary flight display, the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the pitch ladder, the pitch altitude of the aircraft in flight, 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20 degrees for pitch up or pitch down. Also the bank roll. We can bank roll like 5, 10, 15, 30, 45 degrees over here. You will see how many degrees, the side slip also indicator. We have the wings lever over here of the aircraft. Also the barometric altitude above this level. You can see how fast the aircraft will climb and descend. The barometric pressure, also altitude of the outside atmosphere we have set over here in the FS panel, electronic flight instrument panel. So we set the barometric altitude. We have 29.92. It says of mercury right now, or 1013 hectopascals. We can increase or decrease the value to increase or decrease the altitude. Also radio and barrel, plan, range, menu, map. Also weather radar, traffic and terrain on the display. This is for the navigation display function also. So we have the barometric pressure set, the barometric altitude. We have also the pitot dynamic tube and the pitot static for the airspeed and the altitude are controlled from the air data computer over here. You can see the air data computer of the aircraft. It controls many functions, the GPS receiver, magnetic, North Pole versus geographic North Pole over here, displayed in the navigation display and the HSI. So now we have the magnetic 332. You can see here is the Düsseldorf Airport EDTL is in front of us. 80 nautical miles is the maximum rate. So the EDTL Düsseldorf is like 60-65 nautical miles away in front of us in this direction. From Lszh airport, we are located right here. So you will see also other information we need to know over here for this flight or any flight. So you can see magnetic heading and track, the radio altitude above the ground level, ADF left and right, how far above the ground we're going to be flying, the vertical deviation of the aircraft and the distance in nautical miles. You can see 80, 40 nautical miles, over here 20, and this purple line is the flight altitude of the aircraft. We have selected from the autopilot flight director system panel. So if we look closer, the distance, you will see more mountains, 20 nautical miles, 10 nautical miles. We have to fly above the mountains if we fly straight. Also the altitude again are displayed, also 10 nautical miles. You can see green and yellow terrain below the aircraft when we fly, red is above and in front. So So we look back to the 18 nautical miles. Also we have the vertical, the primary flight display, the flight mode announcer, autopilot, flight director system panel, the airspeed, no V-speeds, airspeed selected and altitude selected. Also here we have radio altitude, which was gonna give us 2,500 feet above the ground. The vertical rate of climb descent of the aircraft when we fly, vertical speed indicator. So it's gonna give us 500, 1,000, 1,500, 2,000, 3,000, 6,000. Feet is the tick marks displayed for climb or descent, how fast we climb or descend. The aircraft, we need to pay attention to that mostly, how to know whether we climb or descend, or the altitude difference. So I'm gonna show you also a few more things we need to know about the aircraft systems before going into flight. So we look up most of the systems of the aircraft. I'm gonna show you also the autopilot flight director system panel. So the autopilot flight director system panel over here. The engines indication, the ACAS, as you can see. Also the thrust levers, the flight controls. So I'm gonna show you, as I told you, I control the computer. I have the side stick inputs over here. So I have the computer, the mouse pad over here, and the side stick I use to control the aircraft flight controls over here. So the side stick is the same one like the Airbus side stick, identical. Lszh Extreme 3D, so you can climb the aircraft. You pull up and pull back and forth the Boeing control column of the yoke of the Boeing 787. You see both sides move together, the captain and first officer. Also make turns right or left. The side stick left and right in the Airbus is the control wheel of the Boeing aircraft. No difference at all, same flight controls function. Also you see outside when we move the flight controls or flight controls movement. So I will show you also a couple more things we need to know about the flight controls. I will talk to you right now about Newton's physics, aeronautical and aerospace engineering, and the Bernoulli theory of fluids. I'm gonna show you some principles we need to know for the air transport pilot license and the commercial pilot license. We need to know the aerodynamics and the flight dynamics of the aircraft and the flight principles. So you will see the outside view of the aircraft, and I will explain you also the flight control systems the same moment, the same ways. So we have here, you can see the outside view of the aircraft. You can see the forward wings of the aircraft hold the weight of the aircraft when we fly. The weight of the aircraft is divided over the surface area of the wings, which produce aerodynamic lift force when we move forward the aircraft. So we have the Z engines string to move the aircraft forward. This is a Z aircraft. You can see the Z plus over here, the exhaust cone of the engines, also the bypass from the front fans. Over here we have the front fans. We have the low pressure compressor and turbine in the front, and the high pressure compressor and turbine in the back side, the exhaust cone over here. So you see the bypass is this section. So we have also the fuel lines in the top surface of the wings, also the wing and engine at the eyes. So we have the left wing and the right wing fuel tank, 30% and 30% and 10% in the center tank. Also we have the mean aerodynamic chord position is 23% of the Mach. Over here is where the maximum aerodynamic lift occurs in the forward wings. Is also the position where the center of pressure is moving back and forth when we fly. Also the stall will begin in the top surface of the wings when we fly. The airflow becomes detached from the top surface of the wings, and we have the wings and the aircraft stalled. So we need to monitor here in the primary flight display. You see the airspeed indicated. You will see when we fly we have a red and amber indication just below the airspeed and the angle of stall. So we need to avoid the stall. We pull the side stick or the yoke down, and we advance the thrust levers to increase the airspeed of the aircraft, like this. So this is stall avoidance, you'll see later in the air. So we have the main aerodynamic cord, also is the center of gravity here, where this main aerodynamic cord position is where the yawing axis is for the aircraft. We control the yaw using the rudder, left and right turns like this, mainly. So I have the side stick rudder over here, I can make turns left and right, and the aircraft is in the rudder pedals. You can see you can control the rudder using the rudder pedals, left and right turns. Also we have the interconnected forward nose wheel of the aircraft. We use for the nose wheel steering the tiller both sides in this aircraft, the Boeing 787. So we control both rudder and the vertical stabilizer, the rudder, and the nose wheel steering. Also the toe brakes, we can brake the aircraft. We press the toe brakes of the top surface of the rudder pedals. So we have the rudder. Here you can see we have the nose wheel. I told you we control with the rudder pedals or the nose wheel steering. It deflects 76 degrees either left and right side from 0 up to 45 nautical miles per hour airspeed. Then we have the rudder becomes aerodynamically effective above 45 nautical miles per hour or 72 kilometers an hour in takeoff or in landing, inverse. So from the computer automatically the forward nose will decrease its deflection from 76 to 7.6 degrees. Then as we increase the airspeed for takeoff above 80 knots, usually like 144 kilometers an hour, the forward nozzle from the computer will be locked to 0 deflection. So we have only a very small deflection of the forward nozzle, and we have only the rudder aerodynamically effective above 144 kilometers an hour in takeoff or 80 nautical miles per hour. Or in landing we have the inverse. We have first the rudder aerodynamically effective, and then as we decrease the airspeed we have the nozzle coming in for control the aircraft, directional control. So this is directional control. In the air you have on the rudder, so the rudder pedals again. We have also over here you can see another axis we have is from wingtip to wingtip is the pitch axis of the aircraft. So in the pitch axis you use the elevator of the horizontal stabilizer of the aircraft for climb and descent. In the Airbus is the side stick back and forth, you climb and you descend. In the Boeing is the yoke control column back and forth, so you climb and you descend, same like in the Airbus using the side stick, no difference at all of the flight controls. Also this is called the control column of the yoke. You take the weight up and you take the weight down for climb and descent in the air. So we have also one more axis is the longitudinal axis from nose to tail. It transverses all other axis is the side stick over here in the Airbus, left turn or right turn. You use the ailerons and the spoilers of the Airbus aircraft, or if you're flying the Boeing aircraft you have ailerons, spoilers and flaperons also to make the turns using the differential pressure between the left and the right wing. It changes the aerodynamic lift like this and you make turns very easy. The longitudinal axis is the roll axis of the aircraft. So you use the side stick left and right in the Airbus aircraft. You use the control wheel of your yoke in the Boeing aircraft of the yoke to make left and right turns or balance the aircraft in flight. Very easy, simple principles. Climb and descent, make turns left and right. Also I will show you a couple more things about the flight control system. You need to know over here we have also the bottom surface of the wings is more flat here using the burning material fluids. When we accelerate for takeoff we have lower airspeed, which pressurizes the wings and the weight of the aircraft up into the air. Also the top surface of the wings is more curved, so the airflow is moving faster above the wings, which creates lower air pressure, which sucks the aircraft weight and wings up into the air. So we go for the right systems now. So we have here the horizontal trim stabilizer, the tail stabilizer. So I'm gonna show you how to trim the horizontal tail of the aircraft when you fly. You use these trim switches for the Boeing 787. Other aircraft have the trim wheel also over here, like 737. 787 is automated a little bit, so it doesn't need this way of trimming. Also the Airbus have trim wheels, so you can see we have the trim switch here. When flying we can trim the elevator up this way and pitch the nose up, and this way you trim the elevator down and you pitch the nose down. Is this aerodynamic effect, very easy. So you can read also the tag, what it says over here: elevator trim, left click down, right click over here up. So this is the elevator trim over here, up and down. Trim up and trim down. Also the airspeed, the flap speed over here. We have also the autopilot disengage over here, this small switch, and the head up declarer over here. So we have also, you can see in the screen over here how many degrees you pitch up or pitch down. The elevator, the stabilizer, nose up and nose down, stabilizer trim 4.25 degrees right now. Inside the green button is for takeoff setting. Rudder trim also, flaps, cabin altitude, other things we need to know. Pressurization of the aircraft over here display. Also the engines indication, differential pressure. So we have the engines, we'll show you later. The landing gear over here, extend and retract. So also we have the alternate gear over here, the lock override for the gear, also the auto brake system. So we said auto brakes RTO, it will show us RTO or auto brake 1 degrees. Also RTO, auto brakes rejected takeoff. So I will show you a couple more things we need to know. Total fuel on board, the gross weight for takeoff, and the fuel temperature, -6 saturated temperature. So we need to know the horizontal trim stabilizer. So we trim the elevator of the aircraft. For this aircraft, some aircraft trim the whole tail plane, the whole stabilizer. So we have also, I'll show you the stabilizer trim, the manual trim switch channel over here. You can see the tag, elevator trim, left click down, right click up over here. So this way we trim elevator up, this way we trim elevator down. So we have also the alternate trim over here if we don't use the normal. So this is the alternate pitch up, nose up and nose down as we fly. So you trim the elevator up this way and you trim the elevator down the other way. Also we have the parking brakes over here. Armored sun. We have the stabilizer trim cutoff switch over here. We can cut off the stabilizer, the auto trim function. So you see we use the normal, the alternate pitch trim, as you can see, nose up and nose down. And we have the cutoff switch over here. You can read. You can read cutoff, R2 and R2, stabilizer normal. So this is also the cutoff and flow control for the left and right engine fuel flow, which is a different control. So you see here we have the stabilizer We have the flight control computer system. It's a fly-by-wire aircraft. We have them in the auto position. Disconnect. We have a failure of the hydraulics that will affect either the L2 or R2, left horizontal or right horizontal stabilizer, and the elevator trim. We're gonna lose the auto trim function, so the autopilot, the flight control computers will be degraded from normal to alternate or direct mode or mechanical backup, like in the Airbus. So we're gonna lose the autopilot, and we're gonna have problem with the auto trim function. So we come down here. This for our Boeing 737 over here, 757, Boeing 767, Boeing 777, and Boeing 787. We turn on this red guarded switch here from normal to cut off, as you can see, and with this engage the stabilizer trim, auto trim function. We use only the manual trim after, like this in here, trim up and trim down the aircraft to balance in flight. You can see other things we have here: VHF, radio frequency, high frequencies, to light transporter, ground proximity. Also we have the fire extinguisher left and right engine transporter here, also in the rudder trim. So we have also, I'm gonna show you our secondary flight controls, the flaps. You can see retract or extend the flaps position, how many degrees, and now the speed brakes. External retract. Also you can see the flaps position here displayed, flaps fully extended 30 degrees. We have also the thrust levers, left and right thrust lever, auto throttle, disengage over here. You push this switch and you disengage the auto throttle, take off ground, thrust reverse. So we have a few more things to see from the flight controls. I just talked to you about stabilizer trim. I have the stabilizer trim over here, this switch to control in flight the stabilizer trimming. So this Airbus side stick, I have the side stick priority button for the left and the right side, the push to talk, and the autopilot disengage switch for the Airbus. So this side stick left and right priority button, and you use dual input in the Airbus also. And in the Boeing you have both flight controls are interconnected in every movement, also the rudder pedals. Unless you have a failure or you need to take over, you use an override force for either side flight controls, the captain or the first officer. So I'm gonna show you one more view now of the flight controls. So we need to see now one more view of the flight controls of the Boeing 787, then we come for the rest of the systems of the aircraft. So I will show you this view, nice view of the 787 Boeing aircraft flight control systems, control using the Lszh Extreme 3D side stick. So you're gonna see this view now. Hope you like it. Also the computers. So you can see the side stick I have. So you can see we can climb and we can descend, make turns to the left, turn to the right. Also use the rudder pedals. So we climb, we descend. As you can see, climb and descend. So we have a few more minutes to go for this flight. So climb, descend, is the yoke back and forth, or the side stick in the Airbus. Make turns left and right, turns in the Airbus, side stick left and right. In the Boeing is the control wheel left and right. We have also the rudder pedals interconnected and the horizontal trim stabilizer. Hope you like all the functions. Also we have the thrust control over here. These are the thrust levers, increase and decrease the engine thrust produced over here. So you can actuate the thrust of the aircraft, have more thrust available or less. I use this switch, so I hope you like. Now let's take extreme 3D over here. So we can see also the outside view one more time. You can see we can climb, we can descend, make turns, right and left over here. See one more aircraft over here. So we control the flight controls, full flight control movement, right, left, also climb, descend the elevator, and now the ailerons and spoilers. Over here, left and right, very easy, very fast. There is no problem using flight controls. So the speed brakes extended. So you can see also an aircraft is coming for landing. So we made most of the flight controls. That was the lesson for the flight controls tonight. Go to the rest of the systems. So now I'm gonna show you the flight management computer, how to input all the data we need for this flight, how we create a flight plan. So we'll input the takeoff gross weight of the aircraft, that includes the empty weight plus the passenger plus the cargo plus the fuel board, where the fuel is on the left and the right wing, in the center tank, how much we have it, 30% in the left and the right wing and 10% in the center tank. The flight management computer is gonna calculate the center of gravity of the aircraft from takeoff, climb, cruise, descent, approach and landing. During flight we burn fuel, so the center of gravity is recalculated. This affects the auto trim functions, the automatic trimming of the aircraft, and the flight control computer's function, and the inputs from the autopilot flight director system panel. So this calculates the center of gravity, the minute aerodynamic chord position for takeoff, the Mach also, the horizontal trim stabilizer position, 4.25 degrees for this flight. So we have 23% for the Mach and 4.25 degrees. Also we use 15 degrees of flaps for this flight. I'm gonna use the runway data. So we have the runway here. We're gonna use for this flight, which is the runway 14 in the Zurich International Airport. You can see the runway length over here, the threshold and the length. So we have the runway. We're gonna set it in the flight management computer here. The runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, and the temperature of the air. Also, the runway conditions. If we decide right away, we're gonna have the calculations about the takeoff speeds, V1, V-rotate, and V2. We're gonna use full takeoff power, like 99-100% of thrust available, and we're gonna have a pitch attitude of 9 degrees of takeoff rotation. Also, we're gonna have 140 knots, nautical miles per hour for takeoff, and plus 15 knots for V2, plus 15. So we're gonna have also the seas, the other instrument departure waypoints and fixes, and include horizontal, vertical, and altitude and speed navigation fixes. We're gonna climb to the cruise level. Oh, you can see also here we have another aircraft coming for landing, a Boeing 737-800 over here, as you can see. So here we are, it's coming in for landing. It's all spotted. So we have the runway, length, the runway slope, the wind direction and speed. We're gonna have the seas, the southern instrument departure waypoints and fixes, that include horizontal, vertical navigation fixes, and airspeed constant. We're gonna climb to the cruise level. like 35, 36, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints, make some turns. We're gonna initiate the descent. After the top of climb, we have the top of descent. We're gonna descend back to the elevation of the airport, like 76,000 feet above the sea level for the terminal approach and landing. The long final, the short final approach, the stars. These are the terminal arrival waypoints and fixes. We're gonna be aligning the runway heading to this stars. We're gonna have also the magnetic north pole heading tuning the autopilot for using the Lszh localizer, the instrument landing system that transmits radio frequency from the threshold of Dennis. The Lszh localizer, which signal we receive from the onboard antennas of the aircraft, would tune a unique radio frequency for each runway we use for takeoff and for landing, and a heading unique for this runway. So we're gonna have the onboard antennas of the aircraft receive the radio signal. We're gonna be aligned with the localizer and the vertical glide slope. The approach angle, we're gonna use the angle of approach. We're gonna use 25-30 degrees of flaps for approach and landing. 160, 170 nautical miles per hour airspeed, like 270 kilometers an hour. Pitch altitude of 9 degrees and landing gear extended, so you're gonna see the complete flight of the aircraft, also the flight line or flight path route. So I'm gonna start now using this mouse pad to create the flight line over here. You can see we have the flight management computer, also the mouse pad here, the touch screen, the keyboards. So we use the index here, identity, position, performance, takeoff, approach, annunciate status, navigation data, flight plan, loaded traffic control, load flight plan. So we're gonna use here the control quadrant over here. So you can see again one more time what we have for display. So I'm gonna use the flight management computer, create a flight plan. So we have the identity is a Boeing 787-900 ZNX engine, the index, position, again reference airport. We can use this to align the aircraft with the inertial reference systems. So we have also here performance, zero fuel weight plus fuel on board, takeoff gross weight, the cruising altitude, cost index, fuel freezing temperature, cruising center of gravity, and reserve fuel for this flight. So we're gonna use the route first, Lszh airport, Zurich International, origin, copy paste, destination over here. So we clear over here, runway 14 for takeoff. Then for landing we have departures over here and arrival. So we select departure runway 10, 14, 16, 28, 32. You can select either runway, so we select runway 14, and the seats, the southern departure waypoints and fixes route to Alpha. So we have departures, arrivals over here. So we select arrivals, VOM 16, VOM 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14 localizer, 28 localizer 34. So we use ILS 14 Trans-Amity, Trans-Negria. So we use this transition altitude and airspeed. The flight plan is not yet activated, displayed with blue. First waypoint, climb to the Zui, make a turn over here, then climb to the Negria, then descend, approach and landing, Zurich 701. So we initiate fuel on board, zero fuel weight, just fuel on board, gross weight for takeoff, reserve 5%. For this flight with this cruising altitude 35,300 feet, cost index 100%, fuel freezing temperature minus 37 degrees, and the cruising center of gravity. So we need to execute now. Press the execute button, it will activate the flight plan. So we have the first waypoint, 136 degrees, 135 heading to nautical miles, 250 knots, 1900 from the runway threshold, 1 nautical miles, 3, 5, 6. We make a left turn here, heading 052 Zui, 6 nautical miles, 301 knots, 6000 alpha. Then heading 071 is the Negria, 26 nautical miles from Zui, 301 knots for 22,200. Then is Mari, 230 heading 12 nautical miles. We make a right turn, 320 knots, 11,000 with descent for approach and landing. Amiki 6 nautical miles, Zurich 9 nautical miles, Zurich 701, 290 heading, 6 nautical miles, 186,000 alpha. TRA 10 nautical miles, CY14, 6 nautical miles, Osman 5 nautical miles, 136 degrees. We make a left turn to align with the runway. 170 knots, 4,000. Runway 14, 8 nautical miles. So this is the flight plan one by one. We use also initialize flaps, center of gravity, and trim 33%, 4.35 degrees. V1 we rotate, V2 gross weight on the runway. So we have other things to use: departure arrival, alternate, VNAV, progress, and the communications. We can hold over a waypoint in flight, fix, and also the navigation radio. We can tune the radio of the aircraft for ILS or board station ADF. So we go back over here and we have a few more minutes. We created the flight plan, as you can see. All the waypoints over here are displayed in the navigation display, as you can see. Also in the HSI, so you can see the vertical profile and the horizontal when we fly. The waypoints we have to fly through. Also here, a bit closer, you will see one waypoint by another. Approach and landing here. You can see also the runway we use for takeoff and for landing. If we look closer, the runway length over here, the taxiway and the aircraft, also the terrain. You can see this taxiway in this airport here, the runways from the GPS system, so you can guide your aircraft where you need to be in the terrain. Also in the airport, you can see this guidance. Also we have this view over here for navigation, map setting. Also further away you will see a few more airports over here, the runway and the flight plan we have created. So we need now to go over here. We're gonna use now overhead panel, start the APU. I'm gonna start the APU, auxiliary power unit. We need to start the engines, APU in the start position. We have the left and the right IDZ, the great drive generator, left engine driving, right engine driving, 130 200 volts, 400 Hz frequency, the battery, 120,000 kilovolts, the primary flight control computers in the auto position. Also over here, air data computer, flight control surfaces, battery, FD door, towing power over here, passenger oxygen, window heat, the ram air turbine backup for the hydraulics. We have the left and the right engine driving, and the electric C1 and C2. So we can turn off. You will see the fault displayed and back to the on position and to the auto. The controllers for the hydraulics. Fluid, we have electric also, which are air pressurized from the engines. We have the wing and engine radii from the engines, also hot air. And also you can see over here we have pressurizer for air conditioning, ventilation, hydraulic fluid tanks pressurization, wing and engine anti-ice. Over here hydraulic fluids and cabin pressurization and oxygen in flight. So we use the auto. In the manual we have the outflow valves when climb descent, increase and decrease pressurization. And also using the auto we need nothing to do. We have also the recorders, the cargo and APU fire over here, the electronic engine control for the engines, the auto start. We use here the start switches, the electronic engine control for the engine, alternate and normal modes. The nozzles, we can arm this and make an emergency landing. We dump some fuel and select the nozzles and how much fuel to remain. This is the fuel jettison of the aircraft. We have also the fuel system, left and right wing fuel tank, center tank, the crossfit valve with an automatic feed either engine with either pump or either tank, and balance the fuel between the left and the right wing. So this is the crossfit what it's doing. We have also the fuel booster pumps, the normal, the aft and the forward. So this is what we need to know for the overhead panel. You will see now all the systems we see in the display. Here also we need some lighting, maybe for making the engine start demonstration. So we have the engines start demonstration in a couple of seconds. So we have here systems. You can see the hydraulics, pressure, oil, APU is running, oxygen and liquid cooling. So we have the electric over here, left and right IGZ, the great generator, the APU is running, the load state of the aircraft, also the main battery and the APU battery, the voltage and the average. The hydraulics, left engine driving, right engine driving, electric C1 and C2, which flight controls use hydraulic fluid, also the pressure of the hydraulic fluid 5100 and the quantity of hydraulic fluid. The fuel system, left and right wing, fuel tank, center tank, the engine, left engine, right engine. So we have also the minimum fuel temperature below which the fuel will freeze here, minus 37 degrees. So you can see we have 11,000, 11,000 left and right wing, balance, center 11,000, total 34,000. Low and high pressure fuel valves open and feed both engines, either from the left or the right wing. And the center with the crossfeed valve here is off, but we turn it on, you can feed other engine with other pump or either tank. And balance the fuel between the left and right wing. The APU is fed from left wing using DC motor. Also we recirculate the fuel in flight automatically from the FAREX, because otherwise the fuel would freeze in flight. So you can see here the minimum fuel temperature. So the FAREX, the Flught, these electronic control computers, you see minimum fuel temperature here minus 37, and the fuel temperature right now minus 6. Automatically recirculate the fuel from the wings and the center tank into the engines components to heat up the fuel and also the lubricant and the oil, so otherwise they will freeze in flight. We have also the air pressurizer, air conditioning, cap pressurization, oxygen. The doors are closed, the cabin can be pressurized. Also the gear, you can see the pressure of the tires and the temperature of the brakes. Nozzle, also flight controls. You can move flight controls here. You will see iron spoilers, the tail movement up and down, and the rudder, also the stabilizer trim. So this is one of the last things to know before going to flight, the flight controls. We have also the FS display over here, status, maintenance and circuit breakers, also digital circuit breakers, the checklist, what we need to do before going to flight, normal menu, before start, after start, takeoff, approach, landing. We have the communications also and the navigation display. So we'll go back navigation display over here. You can see we turn off both engines right now. We can go for the engine start process. So we set fuel control, fuel valves to the off position. So you see we have fuel starvation right now. The warnings coming up. So you can see here we need to restart the engines now. The engines are off, as you can see, of the Boeing aircraft. So we go here in the overhead panel, we set the auto start in the on position, both auto start position. You see the yellow reconfiguration switches in the overhead when we start the auto start. Also we have pressurizer from the APU is admitted into the engines. So we have the N1, which is the low speed starter sub, low pressure compressor and turbine of the turbofan turbine engine, the exhaust gas temperature, the N2, which is the high speed starter sub, high pressure compressor and turbine of the turbofan turbine engine, the fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we can admit the fuel now. We have enough pressurized air into the engines. Fuel valves over here on, both fuel control to the on position, run. So we have the auto start is coming in above 24% over here. So we have 49%, 50, 51. You can see the yellow indication going off, the amber color. So we are almost ready, 61%. We have running both engines. We have one thing left, flaps up for takeoff, speed brakes up, and we need to set up the autopilot over here before going into flight. You see we have the autopilot engage and disengage switch, the LNAV and the VNAV over here. We can use the flight director on and off. We can turn off both modes, the auto throttle left and right, arm and disarm, also the airspeed, climb continuous auto throttle. We can set the airspeed like below or above, whatever we need, very fast. I'm gonna set it like this. Autopilot disengage over here. Flight level change, each one is doing something different. Bank angle also heading. Gonna set the heading of the runway. Gonna have for takeoff over here. We can also select the bank angle. We have 0 level off here, vertical speed. We can descend. You see the minus sign, VS, or climb. We have the plus sign over here. So we're gonna climb with 3,500 feet per minute. Also the altitude, we're gonna set in thousands. We have the roll localizer, the approach for autoland. So this is the autopilot set. So now we're ready for takeoff. We taxi into takeoff. Stay with me to see the full manual flight. Advance the thrust levers. Parking brakes off. Over here. Use the tiller. So idle thrust. The runway is open for us from the air traffic control. We have no traffic, so we can use the runway for takeoff. That's aligned with the runway heading over here. So we use the tiller here for alignment. So this is the tiller control, the nose wheel steering of the aircraft. So we advance the thrust levers forward, like this, as you can see. Full takeoff power. And we press the yoke of the Boeing or the side stick of the Airbus up to 80 nautical miles, like halfway down, as you can see. So we have 100 knots, 120, V1. We rotate 9 degrees. So we have the positive rate of climb over here. So we pitch up the aircraft a little bit, not too much, it's not needed. So you can see around you as we take off. You can see the indications from the aircraft, the terrain, red, green, yellow, horizontal. We are 1,900, 2,000 feet above the ground, but 3,700 above the sea. The airspeed 180 knots. We need also to pitch down the aircraft a little bit. The wind direction and speed here, the flight plan we're gonna follow. Also you see we climb with 4,000 feet per minute. You can see the air data we have. Also the terrain, if we look further in front. Also the engines indications, the terrain, we look further, like this. So we have a closer terrain look. You can see the terrain below you. We are 4,000 over here. As you can see, 4,500 feet above the ground. 4,600. Here is the aircraft symbol. 4,000 feet above the ground. You see this green line. Below us is the ground. also around us. So we look up the airspeed, and now we keep landing gear up, also landing gear up over here. So we retract the landing gear. So we see the runway over here around us, the airport. So we initiate the turn, and we have like 18 more minutes for the video to end. We make the turn here. If we have some time, maybe we're gonna use the autopilot for a couple of seconds. So you will see the autopilot use. You can see we keep climbing over here. The air data, the airspeed over here, 157 is stall speed, the wind direction, the speed, the ground speed of the aircraft. We need to cross through this waypoint, and now the altitude, the elevation of the aircraft above the terrain. So this is the aircraft after takeoff, the cockpit. So you see how we climbed over here. So this is the outside view of the aircraft. So we keep climbing. We need to align with the flight plan, make some left turn over here, some right turn actually. We need to follow the waypoints here. Keep climbing. So you can see a very beautiful view over here of the aircraft. The Boeing 787. Have a gorgeous view over here. So you see the Switzerland, the lakes, the Swiss Alps over here as we're flying through. So we need to align here with the waypoints. So we have the Zui first waypoint over here to cross through. You can see Zui 12 and 1.8 nautical miles, 1.7. Use the LNAV also function. So after we align with the waypoints, we may tune the autopilot for a couple of seconds. You see how we use the autopilot for a climb. So we cross through 20,000 feet over here. We have the next waypoint here, the Negria, the airspeed right now, the altitude we have. So we turn on the autopilot like this. It will align us like this, as you can see. We have the autopilot engaged right now for guidance. AP, autopilot on. So we climb through 20,000, 21,000, autopilot on, 20,000 feet, and we follow the waypoints here, 220 knots. We have the LNAV, the altitude hold also, vertical speed. You see autopilot engaged. So we may go back to the airport in a couple of minutes over here. So we overflying the Zurich here, the Germany, my homeland, Bayern Munich in front of you, the France. So we need maybe disengage the autopilot now and make the turn. We can also use manual trim, manual flight controls. So we make the turn here, as you can see. We overflying Switzerland over here. The Germany, Bayern Munich, my homeland, France. So this is the beautiful view of the Boeing 787. As you can see. Now we fly manually again. Maybe we use the autopilot later. So we cruise over my homeland, Germany. You can see also the Boeing 787, very beautiful view over here. It pits down, and we have the chemtrails. Also a little bit more of turn. Over here. So we're gonna be aligned here with the flight plan. You see over here. So we fly manually again. We turn off the autopilot. We have the flight director on. So you see we need to cross through these waypoints here. So we cross through over here, overflying the France, the Germany, my homeland, Bayern Munich behind. You can see the Germany behind. Also this beautiful galactic view over here, and we're leveling off, overflying the Germany, Bayern Munich behind us, and the France. So this is the most beautiful view you can have here. 36,000 feet right now, and we're gonna start the descent. We're leveling off, and we initiate the descent of the aircraft. So we start the descent. Idle thrust, speed brakes extended, upside. So we keep descending over here. So keep descending, idle thrust, overflying the airport over here, as you can see. And we have 6 more minutes for approach and landing. Increase the rate of descent over here. You can see the cockpit one more time, just before we go for landing. So now we fly manually with descent, increase the airspeed, as you can see. Now we're going with Mach 0.645, leveling off a little bit. We need to keep descending. We need to fly through these waypoints for approach and landing over here. Also the other side, you can see the autopilot is off right now. We turn it off. Also the engine's thrust is in the idle. So we need to keep descending over here. Increase the rate of descent a bit, and we have 5 more minutes to go for landing. So we may start the turn right now, as you can see, as we keep descending. We are 13,000 feet above the ground. Use a little bit more idle thrust over here. So keep turning. We need to also increase the rate of descent. And make the turn now. Need to align with the runway. We use a little bit left rudder for this turn, because we're going to be aligned with the runway in a couple of minutes. It goes through this cloud here, as you can see. So we have the runway in front of us over here, as you can see. We can use landing gear down, flaps extended over here. For approach and landing, we need to align with this line over here. Also, maybe we are a little bit higher. We need to use flight controls for alignment here, as you can see. Right rudder pedal now. We use right rudder to make a right alignment, left rudder now to make a little bit left alignment, a little bit more thrust. Engine power. We need 2 more minutes to reach. So we're gonna have this nice view over here for approach and landing. Align again with the center line, and we have 1 more minute for approach and landing. You can see we follow the Lszh localizer over here. All the information we need is here in the primary flight display, the navigation display. So we have a little bit side wind. We use right rudder, also flight controls to the right. A little bit more thrust will give us better flight control maneuvers when we have side wind, and wind gust is pushing us to the side. Also use more flaps over here, so we need to increase the airspeed. We have about 1 more minute for the video record to end. Few more seconds. Align with the runway, center line over here. Idle power, pull down. So we align with the center line, use flight controls. We're gonna be leveling off for the flare now. So we flare here, as you can see. Beautiful touchdown, very beautiful touchdown. Idle thrust, thrust reversers, and parking brakes. So we're slowing down right now. Full thrust reverse over here, and align with the center line, as you can see. So this is how we're slowing down the aircraft over here, center line.